Okay, in this scenario with priority donation in Pintos, I'm going to have three threads and two locks, lock A, lock B. And T1 in its program is going to acquire lock A, and so it becomes the holder. And it's going to acquire lock B, so it becomes the holder. Now T2 is going to request lock A, kind of in our simple example. And it's not going to be able to acquire it because it's being held by A. So it's going to add itself to the waiters list. And the effective priority of A is going to change due to donation. Right now, the effective priority of T2 is 12. The effective priority of T3 is 20. The effective priority of T1 is 10. But given this donation, that just has happened because T2 wants to donate to T1 because T2 wants something that T1 has. So it really would like T1 to progress to the point where it releases that resource. So it would donate, meaning it is now operating with effective priority 12. Okay. Now T3 requests lock B. Which is held by T1. So it would add itself to the waiters list, and donation would occur. Right? T1 is receiving a donation from T2 that makes its effective priority 12. T1 itself has priority 10, and now T3 wants to donate to T1. So T1 would operate with the max of those priorities. So the effective donation would turn this into 20. Right? The max of 10 and 12 and 20 is 20. Okay? Now let's say that T1 releases B. What happens when it releases B is that it should give up the donation priority, right? It should no longer be operating with priority 20. So it needs to drop its priority, but it doesn't drop it back to 10. It's still effectively getting a donation from T2, so it should drop back to 12. Okay, and I haven't updated my picture. There are some other things that changed when it unlocked, right? This becomes null because it no longer holds that. And what likely happens is that now T3 is able to acquire the lock, and that happens. So I could draw that picture that, like, in the near future, this picture will end up looking like this. Now, if T3 then in its program decides to request A's still being held, so it wouldn't get it. So it would add itself to the waiters list, and it would donate priority again, this time directly through A. And so we go back up to 20. And then the system would keep chugging along, and at some point T1 would release its lock. It would set itself so it no longer owns the lock, and it would drop its priority down back to what its donors are. But these two folks, T2 and T3, would no longer want to be donors to T1 because the thing that it had, that it wanted, it no longer has. So any donations that came via A, no longer relevant. So the effective priority drops back down to 10. And then because this is a priority queue, the next thing that would run is T3. Right, so T3 should acquire the lock because it has priority 20, and so it would be scheduled before T2. So this picture would change to take T3 out of the waiting list. It would become the holder of the lock. This arrow would go the other direction to show that A had been acquired by T3, and the program would continue. And because we hand them out in that order, the question of like, well, what about this? There should be donation from T2 to T3. Yeah, but the higher priority thing always gets scheduled first, and so we don't need to worry about T2 donated to T3 because it's of lower priority. So as things come out the waiters list, they're coming out in priority order. And so we only need to worry about when new people enter the waiters list, not when the waiters list moves. I'll go through another scenario in the next video.